Today I will be building this spherical desktop speaker with the help of the Creality Sermoon Pro V1 3D printer sent to me by Creality, and I will also be finishing it in a way that gives it a beautiful and shiny metal look finish. So stay tuned to see how I do this, and by the way, I will have build plans and all the STL files for this project on sale on my website at soundblab.net. When I first took this 3D printer out of the box, I thought this looked a bit like a toy. It does not have a very industrial look, but rather domestic appliance looking, and the build plate is small, only 175 by 175 by 165 millimeters. However, after setting it up, a very easy and quick process by the way, and making my first print, I quickly realized that I couldn't be more wrong. The spaceman model that was on the supplied SD card came out almost 100% perfect, printed with a supplied roll of white Creality PLA that came with the printer. Lay lines are perfect, the supports did their job and removed easily without leaving any rough surfaces behind. Even this XYZ cube looks amazing and measures very accurately at 20 by 20 by 20 millimeters. So out of the box, this 3D printer performed without fault. Despite the small build plate volume, over the years that I have been using 3D printers, I've realized that most prints that I make will easily fit into this volume. So do not be put off by the seemingly small build volume. I wanted to put this to the test, so I set out to design a very functional and good sounding desktop speaker. The driver I chose to build around is the Levoche FAN030.71 3-inch paper cone full range. It has a very good sensitivity at 89.5 decibels and good power handling of 30 watts. Frequency range is limited at the bottom end, but we can pair this with a subwoofer to cover the lower frequencies. My first design was a perfect spherical ball. However, this had to print with lots of support material. And even though this will be perfectly usable, there are some artifacts left behind on the surface around the bottom due to the support material. This is not a shortcoming of the 3D printer, but rather the process of FDM printing. Back to modeling, and I changed the design to allow me to print the model without any supports. Looking at a section view, you can see that I've made sure that I do not have any angles in the model that exceed 45 degrees. So now it's not a perfect sphere anymore, but printing is much easier and I still like the design. And for some reason, when looking at the section view, it somehow reminds me of an eyeball. And so these have been christened the SoundBlab EyeBalls. I used the matte PLA for these prints, and this is the result of the printing without supports. It came out mostly perfect with only two weird parts at the top and the bottom. However, when I printed the second model, these were not there and it was perfect. I stuffed the sphere with some polyfill and mounted the driver. From the measurements taken, we can see that it drops off around 150 Hz and it has a rise from 1400 Hz and a significant peak at 11,000 Hz. Overall, the mid-range is wonderfully flat though. The rise and peaks will be corrected using DSP. I will be connecting these to an Arylic 2.1 amplifier board, and this gives me the ability to use the built-in DSP processor to correct the response and to select an appropriate crossover frequency to the subwoofer. By the way, I'm designing a matching subwoofer enclosure for these speakers, but will use a different method from the FDM printing to make it. Make sure to subscribe if you want to see more of that upcoming project. You can also support me further by becoming a patron or joining as a YouTube member. I post behind the scene updates on my current projects almost every week on these platforms, and it's a great place to get involved and provide your input into the projects that I take on and become part of a community of like-minded people. Links are in the description below. I also designed stands for the spheres and tried to print these in PETG and ABS to see if this enclosed printer can handle these materials. The PETG printed well, but I did have some lifting from the build plate on the far edges. Similar was the ABS, which I stopped when it started to lift. However, I also tried to print the smaller XYZ cube in ABS to see if the size will make a difference, and it did. I think success with ABS will very much depend on the design of your model and the size. Too big and the part will start to lift from the build plate around the edges. Printing with a raft might make a difference, but I did not try this. In the end, I opted for wood-filled PLA to print the stands with much more success. These TPU bumps fit onto the top of the stand, and these printed very well without issues. I did get a lot of stringing though, but these cleaned up okay afterwards with a pair of snips. One thing I really like about this printer is the fact that you can connect it via Wi-Fi, and with a built-in camera you can monitor the print progress. You can also send print files to it remotely and control the printer via the app or the Creality print slicer. I hardly use the SD card at all. I would just send the print file to the printer over Wi-Fi. The built-in Creality print presets are pretty much spot on, and you would not need to change anything. Perhaps just printing 3 walls instead of the 2, all the presets are set to, and I would adjust the percentage in full according to my needs. The presets also add a raft to most prints, but I would also just adjust this to my needs. The next step in the process is to finish the spherical speaker. And I've opted to go for something quite interesting. I'm quite sure a lot of you have seen other creators making or printing 3D printing Mandalorian helmets, and then they will give it this really nice sort of like shiny metal finish. And in many cases what that actually is something called graphite powder. And what you do is it's quite a laborious process. You have to sand the surface and fill the surface, or to get rid of all the imperfections. Sand it, fill it, sand it, fill it, and then you give it a nice gloss black coat, and then you rub this graphite powder on, and at the end of the day you end up with something that looks like this. So this is the other speaker that I've built, because this is a stereo set. So and it came out quite nice. This did take me quite some time to achieve this finish, but I think it came out really good. So what I'm going to do now, I'm just going to quickly go through the process and show you what I'm going to do to make this one look like this one, and then we have a nice stereo set. So let's go do that. I start by using the random orbital sander and 150 grit sandpaper to smooth out as much of the layer lines as I can, and then go over to hand sanding again with 150 grit sandpaper. Any imperfections are filled with a polyester automotive filler and sanded smooth after it has hardened. I also cover the driver opening with masking tape to make sure I do not get any overspray into the speaker enclosure. A filler primer is used to cover the sphere in multiple coats. I sand with 600 grit water paper in between these coats until I get a very smooth finish without any layer lines to be visible. You can now coat it with a regular primer, or do what I did and use a primer and a top coat in one, in a gloss black. I did 2 layers of gloss black, sanding in between with a 1000 grit water paper. You want to get this last coat of gloss black paint as shiny as possible, so take your time when applying this last coat. I've given this sphere about 2 layers of the sanding or the filler primer, and then I've also given it 2 layers of the gloss black paint. I think I could have done maybe with another layer of filler primer, because I can still see a few imperfections on the surface as it's reflecting in the gloss black paint. But I'm running out of time on this project, so I'm gonna just continue with this, and then I'm gonna hope for the best. So I'm gonna take the graphite powder And I'm going to start rubbing this into the black gloss paint, and then you're going to see what's going to happen. It's going to get this really nice metallic look finish. So let's do that now. That's pretty amazing. I just love this finish and it came out great. Of course, you can finish these in any way you want, or even just leave it the natural plastic. The options are really endless to make this design your own. The binding post plate in the back is a separate print, and this makes the assembly much easier, since it's very difficult to get your hand in the enclosure through the small driver hole to tighten the nuts on the binding post. The plate just clicks into place and it can be secured with CA glue once the wiring has been done. There are no crossover components, which makes wiring very easy. We just solder a wire between the binding post and the speaker driver. Before the driver is screwed in place, I stuff the enclosure with polyfill as a damping material. Using the gated frequency response of the speaker, where we eliminate the room effects on the response, I can use the EQ function within Room Equalizer Wizard, or REW, to apply parametric equalizing to get my preferred target response. This is what I ended up with. Since this is intended for near-field listening on a desktop, I have tapered the response down towards the high end slightly, but I will include a flat response in the download files together with the build plans. But before we do a quick sound demo, let me tell you my final thoughts on the Creality Sermoon Pro V1. The biggest positive is how well it does straight out of the box. You can start printing within 30 minutes of having it out of the box, downloading the app on your phone and connecting it to your Wi-Fi. The supplied SD card contains a setup manual, so go there first after unboxing the printer. The printer does not include automatic bed leveling, but it does have a very helpful and easy process to help you level it, should you need to. I had to do this once or twice during my printing, and I would have liked Creality to include auto bed leveling to make this even easier, but it's not a deal breaker. The built-in camera is very useful to track the printing progress and can be monitored through the app or the Creality slicer. Print quality is excellent. I did try ABS, but my result was a bit hit and miss. I think printing with a raft is mandatory to make sure it does not lift or warp. PLA is a breeze to print, and even PETG gave me very good results. I like this printer and I can highly recommend it to anyone wanting a no-nonsense approach to their first printer, where you just plug it in and it works. Back to the project, and I love how these came out. I will be using these on my desktop as monitors from now on, pairing it with a subwoofer later on. The sound is crisp and clear with great detail in the mids and highs. They can also go very loud, so do not be fooled by their size. I want to thank Creality for sending out the Sermoon Pro V1 to try out, and you can get your own by following the links in the description below. Pricing is around $500 at the time of this video. Thank you all for watching. Check out my Patreon and YouTube membership pages to support me further, and you will find links to my build plan shop in the description below at soundblab.net, where you will find the build plans and downloadable files for sale to this project. Until next time, adios. Let's do a quick sound demo. This demo does not include a subwoofer, only the stereo set of speakers. Enjoy.
Smoking rooms, wherever you are, it's just about closing time.
I could feel it in my bones. There was something going on. That shit of doubt hanging around. God, oh.
Reaching out for sunbeams, grasping at the light. So